Hello everyone, my name is Kasiriha. I work as a test manager for DB Schenker, and today I would like to show you a library for visual document testing that we developed. So Schenker is a global freight forwarder, and when you think about global freight forwarding, you might think about airplanes, ships, trucks getting freight from A to B, and this is all true. But in fact, freight forwarding is also a lot about documents, like invoices, bookings, customs declaration, all kind of documents. And it's important that we don't have any defects in our documents, because some defects might be awkward, but some other defects might have legal consequences. So we must be sure to get it right. So for that, we have a central output management system. And what we usually do is we send an XML payload to the system and it will generate an output for us. Sounds simple, right? The problem is there are a lot of testing possibilities, because first thing is we have a lot of different documents that we have to generate, hundreds of documents. Then we also have country-specific rules per document, like an invoice in Germany looks different than an invoice in China. We also have different output formats and channels, so we might generate documents via email, we might send them to a printer or print factory, send them as SMS, all kinds of things. And we have different applications that send the data to our output management system. So when we create a new release for our output management system, what we usually do is we compare our outputs. So we generate a new output, a candidate output, and compare it to an output we generated before, our reference output. And if it's equal, all good. If there are differences, it's a problem, test failed. In the past, we did it manually. At some point, we decided we want to automate that. However, when we automate document tests, we have some problems, because some values in the documents are always unique and always different, right? So like a unique ID, for example. So we need a way to filter that out. Also, other things like date values might be a problem. So we also need to ignore those things from the comparisons. Yeah, so I will show you some examples in the demo how this can be done with our framework. Then we need to deal sometimes with small differences, which are visual differences, but which are still okay, like a text block which is moved for a few pixels, or an area which looks different visually, but where the text content is still the same. So I will also show you some examples how we can make those things pass anyway. So that's it for the intro. Let's have a look at some code. All right, let's do a small demo. I mean, I could throw more slides at you, but I think a demo will make it more clear. So in the demo, I will show you the basic usage of the library. And what we will do is we will compare two images which look kind of similar. So if you look at those two beach pictures, they look pretty much the same. It's one of those examples from the magazines like please spot the 10 differences. So we will check if the library is able to find those differences. And we will set up a new test suite from the scratch. So let's quickly do that. So I already prepared an empty robot file. And what we will do first, we will, of course, import the library. And the library is called just docTest.visualTest. It has several sub-packages, but for now we will only do the visual test package. And we will of course need a test case, so we will also add that. Compare to beach images. Okay. And now the library only has one important keyword, compare images. And what we will provide as arguments is, the path to the two image files. So I have it in my test data folder. And one was called beach left.jpg. Okay, that's it. Test suite done. So let's run it and see what the library does. So test case failed and we got an error message. The compared images are different. So this doesn't tell much. Let's have a look at the log file. Maybe we'll learn more in the log file. So we got the log file, test case failed. And now what we get here is a nice picture with the highlighted differences. So you can see those red rectangles, right? So those basically show us the different parts in the images. So if you look in the upper right, in the left image, there's no bird. In the right image, there's a bird. and this goes on and on with the other changes. We will also get a merged view where we have both pictures like combined with each other with the red rectangles. So this is helpful in document tests if the text block has moved or something. But we will look at that in more detail later. But yeah, that's the basic usage of the library. And now I have some more examples. So I prepared something. Now this is very similar to the examples we just had a look at. We again compare a beach image. This time for the second test case, we will compare a beach image with a date and an ID at the bottom against a beach image without the date in the ID. And of course, this comparison will fail. And I will show you some clever approaches how to ignore those parts of the image. I also added some more parameters or arguments when I import the library to take more screenshots and also to take a diff screenshot we will have a look at later. So for now, I will just run the library and explain some more details later. Okay, what do we get? 2 test cases failed, 2 test cases passed. Let's have a look at the results. Okay, here we go. So the first one is exactly the same as in the example we just did. So not so interesting. We in addition get this diff image. So this one also shows the differences just in black and white, basically like the computer would see the differences. So sometimes this view is also pretty helpful. Now for the one with the date and the ID, you can see the only differences identified are this date and the ID. So we often have it in document tests that even though we generate the same document in our document system, we have some unique values there that we cannot get rid of, like a date or a unique ID. But the library also has some options to ignore those things. So if we look at the next test case, which is passed, we can see that blue boxes have been drawn over the date and the ID. Yeah. So, and because of the blue boxes, both images are equal and the comparison is passed. So yeah, good for us. Let's have a look at the other one. And here we can see some blue bars have been drawn at the top and the bottom of the picture. And because of the blue bars, again, the tests are passed because the images are equal. So what did we do here? Let's have a look. So if we look at the test cases, we can see that in the last 2 test cases, we provided an additional argument, placeholder file. And in the placeholder file, we provide a path to another JSON file. And this JSON file basically describes the parts of the image which shall be ignored. And in the first one, we used a text pattern JSON file. So let's have a look at that. So in this pattern file, you can define a type, which is pattern, and then you can define a regular expression. And what the library will do is it will search for texts in the image, matching that regular expression, and then will draw the blue box around those texts or above those texts. And we do it here with the date and with the ID pattern at the bottom of the picture. So because of that, we get the blue boxes and those areas are ignored from the comparison. Now this recognition is done via Tesseract OCR. So the library has some text recognition built in. For the second one, we also provide a JSON file as an argument, area mask top bottom. So let's have a look at that one as well. So this one is even simpler. So this time it's not a mask of type pattern, but it's a mask of type area. And for the area, we need to provide a location, which is here top, and a percentage 10. And we do the same for the second area, location bottom, and again, percentage 10. It means that the top 10% and the bottom 10% of the image will be covered by the blue bar. And because of that, the images were equal. So that's basically the magic behind it. Okay, that was the first simple example. Let's have a look at another one. So here again I have a test suite. This time we are comparing PDF files, which is more of the real deal in regards to document testing. So this time I will just compare two PDF documents. Let's have a look how they look like. So this is a reference document, so our expected result. So this is a real Schenker document with some test data in. And we have a candidate document, which looks pretty much the same, just some areas are different. And again, I added some ID at the top of the document. And we also have a date in the middle of the document. And in the test suite, I will again use a placeholder file. I can show that in a moment to ignore those areas. And in the last test case, I do not provide a placeholder file, but instead I provide the placeholder or the mask as a dictionary. So as you can see, you can not only provide files, but you can also provide the mask as a dictionary directly here. And it will also work in the same way. So let's quickly run it. Okay, two test cases failed, which is good. Let's again open the log files. Okay, so here you can see the test failed because some differences were detected. So you can see the red rectangles here. So here on the right document, this area is empty. If I zoom to the left document, you can see something was in there. So yeah, it's a visual difference. Nevertheless, you can see those blue boxes which were drawn. So the text pattern recognition worked also in the PDF document. However, in the PDF document, it's not done via OCR, but instead the text content is directly read from the PDF file by using a library called PDF Miner. So we can directly access the text content of the PDF file to identify the text patterns. Okay, and for the last one, the result is the same. Basically, I just wanted to show that we can also provide the pattern as dictionaries instead of files. But basically everything else is the same. Good, so we can also close this one. And we can come to another example, again about PDF files, and this is a bigger test suite. So this time I have some PDF files where a text has been moved a little bit. So this also happens sometimes that the text block is moved. And of course, that's a visual difference. And normally such tests would be failed. But I want to show you some solutions to that, how you can make those tests passed anyway. So the library has some options. And one option is, if something is different in your image, please check the text content of this different section. And if the text content is the same, please make the test case passed. And this applies, for example, for moved text blocks. This approach works using OCR, so text recognition from the image, or retrieving the text content from the PDF file itself. Then the other solution I have is a move tolerance for moved areas. So if a text block is moved, you can define a tolerance here in pixels. And if the moved block has been moved less than this tolerance, so if it's only moved by 10 pixels, the tests will be considered passed. If it's moved by more than the tolerance, so if it's moved by 30 pixels, the test will be considered failed. So let's quickly run it. Okay, execution done. So mixed results, 3 passed, 3 failed. Let's have a look. All right, so the first test case is failed because the text block has been moved. Now this is hard to see when comparing the images separately. So on the right image, you can see some red rectangle, on the left image as well, but we don't see much. So this is where this merged view is pretty helpful. if I look at the merged view, you can see, something is off about those text blocks. So indeed, they have been moved, and this is a visual difference. Now I promised you a solution how to accept those changes anyway. And the first solution, I can already tell you, doesn't work properly, which is why I came up with another solution. So in the first solution, I said, please, when the text content is the same, recognized via OCR, then make the test case passed. And now the library looks at the moved or the different sections. And the first section, it says, yeah, the partial text content is the same, all good. However, when we look at the second moved text section, it says partial text content is different. So it says partial text content is different. And what the library recognizes is in the first text block, it says RTMOE, but in the second text block, it identifies RTMOFR, which is of course not what's actually shown here. So the text recognition needs some improvement on my end. So that was the point when I decided, yeah, I need to have a different approach of reading text. So I needed this library PDF miner to retrieve the actual PDF content. So on the next one, I do exactly the same thing, but using the PDF miner library. I again check the text content. And now we can see here, yeah, the partial text content is the same in both cases. And the log entry looks a little bit different. So here we can see an entry for this LT text box horizontal. So this is an object from the PDF file read from the PDF miner library. And yeah, basically the text content is the same, just the position is a little bit different. Okay. So the other solution I wanted to offer is this move tolerance in pixels. So what I do here is I provided a move tolerance of 20 pixels, and then the library checks how far has the text block been moved. And the library says, yeah, this image section has been moved by 6 pixels, and this is within the allowed range of 20 pixels, so all good, passed. And the same thing also for the second moved text block. So this is all good. And this recognition is again done visually without reading the PDF content. However, it can also be done by reading the PDF content from the PDF file. And yeah, the screenshots look kind of similar. The log entries are a little bit different. So again, you can see this strange object, LT text box horizontal, and some data. And now it says, yeah, the image section has been moved by 0606 pixels, which is basically 6 pixels. And again, this is within the allowed range of 20 pixels. And the same one also for the other text blocks. Yeah. Okay, that's it. I also added a negative test case where the text has been moved more than the allowed tolerance. So if we go there, we can see this image section is moved 95 pixels, and this is outside of the allowed range of 20 pixels. So this one is failed. And it is. Okay, so this was another demo to show how to deal with small changes. Now the last demo I'm showing, this is kind of an experiment I'm doing at the moment. So I've heard that visual testing is getting more popular. So like doing visual tests to your websites. And I wanted to try out if I can also use my library for visual testing. So what I do in this example here, I actually open a website, so the Amazon website. I go to the main page, take a screenshot, and I go to the bestseller page and take a screenshot. And afterwards, I compare them by just using the same keyword, compare images. I will compare them to a reference screenshot I took earlier. And I want to see what the results look like. So let's run it and let's see. And now we can see some differences identified on the site. So actually some huge differences because the whole page layout looks different. So maybe it was too long ago that I took the reference screenshots. And in the bestsellers, what we can see is when I visited the page the first time, the category books was shown to me. However, when I visited it the second time, the DVDs and Blu-rays were shown to me. So it seems like Amazon really wants to sell some stuff to me and shows me different categories. And I also did a for loop for this scenario, so I did it several times. Yeah, but also on the second time, you can see the page content is different. But in theory, I would say, yeah, maybe it's a starting point to use it for visual testing. Because all the things I showed earlier, like masks for text patterns and so on, would also apply for visual testing of websites. So maybe I find a way to ignore those changing areas. Okay, and a few more goodies before the end. So with this library, I can also check the content of PDF files. So I can check, for example, if certain strings exist in a PDF file. For that, I created a small test suite, and I created a list object which contains the strings that I want to check. And then I use the keyword check text content. I provide the list of strings and the PDF file that I want to check. Let's quickly run it. So you can see one test case passed, one test case failed, and in the failed test case, it mentions the string which was not found in the PDF file. That's one thing. The other thing is, in reality, when we run our document test, we run a lot of tests. So what we normally do is we combine this library with the data driver library, meaning in our test suite, we will only have one test case and we will store the data externally in a CSV file. So that's how it looks like in reality. Let's quickly run it. Okay, everything as usual. Well, the problem starts when you have hundreds or thousands of documents in such a report. Then it's not such a good overview and hard to evaluate the results. So we wrote a little tool to help us with the evaluation. It's just a Python tool, the test result evaluator. And yeah, well, it doesn't win a beauty contest, but it does its job. So I can just load an output XML file. And once it's loaded, I can go through the failed test cases and it will show me the screenshots directly. And the nice thing is I can sort the results. I can filter the results if I want to. And I can also accept the changes. So I can basically flag the test cases I want to accept and then generate a new reference data set out of it. So this makes the maintenance relatively easy. So that's the last thing I wanted to show. Thanks a lot. Okay, quick wrap up. What did we just see? So we saw mostly the visual testing library, how you can use it to compare images, PDF files, and how you can use it for visual testing of your websites. And we showed the possibility how you can ignore certain parts of your documents via masks and how you can accept minor changes like move text blocks. What did we not fully see is the output content testing. So I showed how you can compare strings in PDF files, but there's more to it. So we implemented a parser for several printer files like PCL and PostScript files, and it's possible to read metadata from those files and compare them. If you want more details on the library, feel free to visit my GitHub page. By the time of this video, it should be released as an open source package. And I'm looking forward to hearing your questions, comments, and everything else. So thanks a lot for your time and enjoy the rest of RoboCon. Bye.
Hey, Manny, welcome to RoboCon.
Hello. Hey, hi, Joe. Thanks for having me.
Awesome. Great to have you. So we have just a few minutes to get to questions. Let's do some lightning rounds. First question is from Marie in Slido, and she wants to know, hello, it seems docTest uses OpenCV methods for image analysis, right? PDF library also recognized with Tester Act OCR. Thanks.
Yeah, good question. That's absolutely right. So OpenCV is definitely involved for the visual analysis of the images. So for the actual simple comparison, I use the scikit image library, but OpenCV is also involved. And regarding the PDF check, so I use Tesseract OCR as an option for text recognition because the PDF file is rendered and then I can scan for the text. but I realized at some point that this is not good enough. So I also use a different library, PDF Miner, which can read the text content from the PDF file itself. So without rendering it, but by retrieving the text directly.
So I'm sure you're going to be asked this question all the time, and it's about resolution. Tadu wants to know, how will the library work if the image resolution is not equal?
So by default, if the image resolution is not equal, this is a visual difference, it will fail. What you can do, however, for PDF files, you can define the rendering resolution. Yeah. So if you compare two PDF files at 72 dots per inch or 300, I mean, if they are compared at the same resolution, it doesn't matter. So I can define the resolution as a setting. So this is possible. But for pure image comparison, like comparing a JPEG with a different resolution to another JPEG, it will be failed due to the different resolution. So it's a very simple comparison, I would say.
Great. So Ed wants to know, there was a check to see if text moved on a single page. Will it check if text goes into a second page, maybe due to a page break?
So again, due to the simplicity, this will by default fail as a test case. So if I have such a scenario as Ed mentioned, this will be failed. However, I'm thinking about if the library should be more clever. So this could be achieved by checking the PDF file structure and checking if a text block has been moved to the next page. It's nothing which is implemented yet, but I thought about checking more data from the PDF file itself. So maybe it's something which will be implemented in the future.
Yeah, it's a great start. Pekka says, awesome new library. No questions from me, just wow. So shout outs from Pekka. That's awesome.
Thank you.
Next question is from Sergio. Sergio says, interesting stuff. If you have a move tolerant of 10 pixels, does it mean that the library will do 100 comparisons as you can move 10 pixels to the left, to the right, to the bottom, to the top?
No, it will only do like one comparison. So Maria mentioned the OpenCV library. So it has some clever approaches of finding an existing template in an image, and it will just find this move text block template in the image and measure the distance from the original position. So it will not be 100 comparisons, but it will be one visual comparison by the OpenCV library. Yeah.
Great. What is the tool which you're using in your presentation, Output Result Evaluator? I'm not sure the tool's names. I guess someone saw a tool in your presentation.
Yeah, it's a Python. It's just a Python tool we developed ourselves because we realized when we had so much output tests, we had a problem analyzing them properly in time. So we wrote this little tool. I think I will also put it in the GitHub page that I provided. So it just helps us with the analysis. So it shows the failed test cases and shows the screenshots directly and makes it easier for us or simpler for us to evaluate the automated test results. So I will also put it on the page. It's not a beauty, but yeah, as I said, it works.
Cool. Vanda wants to know, is there a pixel by pixel comparison in docTest.visualTest library?
Yeah, this is honestly the main comparison it does. It is really doing a pixel-wise comparison. So this scikit image library, it has a comparison algorithm. It's not exactly pixel-wise. So you can define like a threshold. Yeah, by default, I set a threshold very low that every detail is or every difference is detected. But in theory, you can adjust the threshold so that it's not exactly pixel-wise, but it has some tolerance. Yeah, but by default, it's just a pixel, kind of a pixel-wise comparison.
Is the VisualTest library open source? And if it is, what license is available in it? Is it available in?
Yeah, so it's open source. I just released it a few days ago. At the moment, I use the Apache license, so it's the simplest license. So it's an open source package. You can find it on the GitHub page I mentioned at the end of my talk. So yeah, it's just a pure Python code there. You can do everything with it you want. In the future, the location might change, but it will remain an open source package because we wanted to give something back to the community.
All right, so I'm a little bit over. I wanted to go through a few of the last ones. Can we validate two scanned PDF comparisons?
Yeah, it's funny. I got a similar question from my company from the RPA department. At the moment, no, this will be like a difference which is detected. If there's a need for such a feature, I think about maybe implementing a way of doing it. At the moment, no, it will fail due to a pixel difference. But maybe raise an issue in the project, and I will think about implementing something.
Nice. And time for one last question. Sorry, the other folks that just entered questions. Is the content of the PDF file if the content of the PDF file is not written in Latin, what approach will you use?
That's also a good question. I got that. So for the pixel-wise comparison, it doesn't make a difference what language it's in because it's rendered and then compared. Yeah. So if both PDF files are the same, this will work. If the PDF content is in a different language, honestly, I need to do more testing. I would say it shouldn't be a problem, but honestly, it's untested. We have different languages, but at my company, we focus on the visual comparison only. So for the content, I really need to add more tests for it. I can't answer.
I mean, I just want to think this is an awesome start. I love visual validation tests, and I love that this is now available free in Robot Framework. So thank you for this. Before we go, Manny, folks probably have some other questions. Will you be in the RoboCon venue? And if so, will it be the light side or the dark side?
Honestly, I before someone mentioned it before in the previous talk, I couldn't remember the both sides. So I don't know. I will be at the light side. Yeah, I will definitely be at the speakers corner to answer some more questions.
Awesome. Thanks again, Manny, for contributing. Really appreciate you. And thank you for this contribution to Robot Framework.
Thanks a lot. Then awesome. Talk to you later, I would say.
Cheers.
Bye.